Welcome students, let us go to another numerical of your potential energy. A spherical drop of water carrying a charge of 3 into 10 to the minus 10 coulomb has a potential of 500 volt at its surface. What is the radius of the drop? If two such drops combine to form a single drop, what is the potential at the surface of new drop so formed? And the given data is 2 to the power 2 by 3 equal to 1.59. It may be given or it may not be given. Okay, so let us go to the numerical section. Okay, so the formula of the potential is what? V equal to Q by 4 pi epsilon naught into R. So first question is we need to find out what is the radius. So you can calculate easily what is the radius. Q by 4 pi epsilon naught into V, and V you know how much V? 500 volt, right? Place all the values. 1 by 4 pi epsilon naught value is how much? 9 into 10 to the 9. Never forget. Into 3 into 10 to the minus 10 Q charge. Here it is given 10 to the minus 10 whole divided by 500. You will get the answer 5.4 into 10 to the minus 3 meter or 5.4 mm. Right? Now let us go to the next section. So our next step is, what is the potential at the surface of the new drop so formed? New drop means combination of drop. Let us apply a trick what we have used in the first year. That is, your bigger drops volume 4 by 3 pi r q, okay, sphere is volume 4 by 3 pi r q, is equal to nothing but combination means what? Twice multiplication of 4 by 3 pi into small r q. Small r is what? Radius of the smaller sphere. So combination of the volume of this one will give this volume, right? So 4 by 3 pi is cancelled. So what the r you will get? R equal to 2 to the power 1 by 3 into r, right? Now the charge on the big drop capital Q is nothing but combination. How much? Q into Q, how much? 2Q, right? Two small drops, right? One drop is having charge Q, so big drop is having charge how much? 2Q. So let us find out the new potential. V dash is equal to formula, let us place Q by 4 pi epsilon naught into R. So this will be your capital R, because we need to find out for the bigger drop radius, right? So bigger drop radius is capital R. So let us place Q value, that is 2Q divided by 4 pi epsilon naught into R is how much? 2 to the power 1 by 3 into R. 2 to the power 1 by 3 into R. This you can calculate by using calculator. Otherwise you can do like this also. 2 to the power 1 by 3, if you will go upper side, it will become minus 1 by 3. This is 2 to the power 1 into Q by 4 pi epsilon naught into R. So this is minus 1 by 3 plus 1 is how much? 2 by 3, right? 2 to the power 2 by 3 multiplied with Q by 4 pi epsilon naught into R. So your 2 to the power 2 by 3 value is 1.59, and what is your Q by 4 pi epsilon naught into R is nothing but, this one is nothing but formula for V. And what is the V given to you? Your V given to you is 500 volt, right? So what is your value you should put into 500? So answer is 795 volt. Thank you. Let us solve another one. 3-point charges Q1 this much, Q2 this much, Q3 this much are placed in air in a line. The distance between Q1 and Q2 is 1 meter, and that between Q2 and Q3 is also 1 meter. Calculate the electrostatic energy of the system. So let us first draw the diagram. So this will be your diagram. Q1 here, Q2 here, Q3 here, and how you can do the work? Your Q1 is a minus charge, okay? Your Q3 is a minus charge, okay? And Q2 is a plus charge. That's why the arrangement I have done like this, okay? It should be in equilibrium. Between two minus, if you place a plus, then they will stay at equilibrium, right? Okay, now what should be the case? You have to do three works, right? What is the work? One is plus minus, you can take this plus towards this minus. Okay, this work done, Q2 and Q3, Q2 and Q3. Another one is Q2 to Q1, right? This is another work done, Q2 to Q1. This is another work done. Third one is a repulsive case. Which one is this? This is Q3 towards Q1, right? Minus and minus, so this will be repulsion. This is a compression case, right? Thank you. Your energy is nothing but combination of all three, that is U12 plus U23 plus U13. So let us place the formula. What is your formula for energy? Q1 into Q2 by 4 pi epsilon naught into R plus, okay, for 1 and 2, that's why 1 and 2. This is 2 and 3, 2 and 3. This is 1 and 3, 1 and 3. Let us place the formula. What is your formula for energy? Q1 into Q2 by 4 pi epsilon naught into R plus, okay, for 1 and 2, that's why 1 and 2. This is 2 and 3, 2 and 3. This is 1 and 3, 1 and 3. Okay, let us place the values. Whatever values is given to you, you place it. Okay, take K as common. What is K? K is nothing but the constant, 1 by 4 pi epsilon naught. Okay, so directly you can write it K, otherwise you can write 9 into 10 to the power 9. Okay, you can multiply this value with this, right? Let us place all the values, and the distance is for 1 to 2, distance is 1, second one is 2 to 3, distance is 1, third one is 1 to 3, what is the distance? 1 plus 1, what is the distance? 2. This is the distance 2, right? Clear? So we will get the answer minus 0.0315 joule or minus 31.5 millijoule. This is your work done. Okay, so let us write down the summary whatever we read. That is, never forget the formula for Coulomb's force Q1 Q2 by 4 pi epsilon naught R square. Electric field formula is Q by 4 pi epsilon naught only R square, right? Only one Q, right? Next formula is your V. V formula is source charge by 4 pi epsilon naught only R, right? Okay, and another formula is capacitance. What is your capacitance formula? C equal to Q by V, right? Let us solve one simple series parallel case numerical. Suppose one diagram is given to you like this: one capacitor here, one capacitor here, okay, one capacitor here, okay, one capacitor here, okay. This is point A, this is point B. Now tell me, is this a series connection or this is a parallel connection? By looking at the diagram, so many students will get confused. Okay, this is parallel to this one, this is series with this one. Okay, no need to do such kind of things. Just see a simple trick as I told in the earlier videos. What is for a series connection? Series connection is only one way from one terminal to the other terminal. C. Starting from A, there is only one line. You have to cross all the capacitor, and with a single line you are reaching to B. So which kind of connection is this? Series connection. C1, C2, C3, C4. This is a pure series connection, right? Now let's do a simple one. this is C1, this is C2, this is C3, this is point B, this is point A. Now the capacitance is asked between point A and point B. Okay, now you can tell, okay, these two are in parallel with this one. Why? Because while going from A to B, this is one path, and from A to B this is another path. If various paths are there, then it will be considered as parallel connection. So which one is series? C1 is C2 is in series, C1 and C2 series, parallel with whom? C3, right? Let us do a very simple numerical again. If you have given a data of voltage 30 volt potential, another one capacitance 20 microfarad, okay, it has asked to you find out the energy. So what is the energy formula? Half CV square. Okay, you have to place this value, okay, 20 into 10 to the power minus 6 into 30 square. Now you will get your answer, right? Your energy, potential energy, is having various formula. One is half CV square as we have derived. Another one is also, you know, one formula, Q equal to CV, right? So what is your C? C equal to nothing but Q by V. Okay, if I will place this value in C, I will get the answer U equal to half into, this will be your C is Q by V into V square. So this and this is being cancelled. You will get half into Q into V. This is one formula, right? Another formula I can get also, if I will place instead of V, I will write Q by C. V equal to Q by C, right, from here. Okay, and again place it at this equation. This will be U equal to half C into V square. V is how much? Q square by C square, right? B square, that's why I have done square and square. C and this one is being cancelled, so this is half into Q square upon C. This is another formula. What is the formula? U equal to half into Q square upon C. Okay, this is another formula, and this is the main formula. Don't forget this one. Thank you.